Hi, this is Misty, and this is going to be a tutorial on how to solve a couple of the problems that you guys are having issues with on the projectile motion practice problem assignment. So let's look at the first one. We're going to do questions 4 and 5 in this video. The first problem, question 4, says a ball is projected horizontally at a velocity of 8 meters per second from the top of a 125 meter high cliff. How high is the ball 3 seconds after it's released? So first I'm going to draw a picture. I've got a cliff that's 125 meters high. It's going 8 meters per second horizontally. And I always just draw mine to the right. It doesn't matter. And it says, how high is the ball after 3 seconds? So I know time equals 3. Now, this question's kind of tricky because it's not asking how far did it fall. It's asking how high is it now. So if the cliff was 125 meters high, I have to figure out how high is it at the end. So to do that, I figure out how far it fell, and then I do 125 minus how far it fell, and that's going to give me how much it is now, like how high off the ground it is now. So how am I going to do that? Well, we use the same two equations for every single problem on this page. We are either going to use the distance in the y direction equals 1/2 at squared, or we're going to use the velocity in the x direction equals distance divided by time. Those are the only two equations that we're using for this. So we're falling, we're looking at the y direction, so we're going to use d equals 1/2 at squared. Squared. Some of you aren't doing t squared, and if you're not doing t squared, you're getting the wrong answer. So I'm going to plug in my distance is 1/2 times 9.8, that's the acceleration due to gravity, times my time, 3 seconds squared. Now you're going to solve for that, and that is going to give you the distance that the ball fell. Now you need to go back and figure out how high is the ball now. It was at 125 meters. It fell that distance. How far off the ground is it? Okay? So question number 5 says a pool ball leaves a 0.6 meter high table with an initial velocity of 2.4 meters per second. Predict the time required for the pool ball to fall to the ground and the horizontal distance between the table's edge and the ball's landing location. So we have a 0.6 meter high table. It's going 2.4 meters per second. Solve for time. Always solve for time. So I'm going to go ahead and solve for time using the formula. The distance in the y direction equals 1/2 at squared. So 0.6 equals 1/2 9.8, acceleration due to gravity, t squared. And I'm going to solve for t. So the answer is not 0.12. If you got 0.12, you're wrong. Do the math again. You plugged it in right, you solved it wrong. Check your equation, make sure your equation matches mine. Once you've solved for t, you need to solve for the horizontal distance, okay? That's how far did the ball actually hit the ground from the edge of the table. So we're going to do that using the formula Vx equals dx divided by t. So use that t that you just found. The velocity in the x direction is 2.4. Solve for d. Now, I've got my triangle. D's on top, V's on the left, T's on the right. Cross out d. I'm solving for d. D equals V times t. So you're going to solve that.